Okay. Last but not least is recapping key features of quadratics. So this should be a nice addition to when you reviewed standard one with graphing and writing, because identifying key features of a form actually helps you to graph it. So just a friendly reminder of the three forms. We have vertex form, standard form, and factored form. So I want to talk about what each form gives you and how we can identify that information. So mathematicians call vertex form for a reason. It's because we can easily tell the vertex. And vertex, which actually ties really nicely to our review of transformations. Vertex form looks like this: y equals a times the quantity x minus h squared plus k. And our vertex is actually just our horizontal and vertical shifts. So h comma k. Horizontal meaning, did I move left or right? And then our vertical shift, up or down. Another thing, or actually I'll talk about that last. Standard form can tell us easily our y-intercept. So standard form is highest to lowest exponent. Since we're dealing with quadratics, that highest exponent should be a2, which you can see right there. And then our y-intercept is actually just our c, or our constant. And then factored form, which we can also call intercept form. We also call it intercept form because we can see the x-intercepts. So factored form, we actually practiced a whole unit on just factoring, and our goal was to get those two parentheses times each other. And factors just mean what multiplies together, so that's why it's called factored form. And your x-intercepts are found, I'm going to change colors, by just setting your factors equal to 0. So if I look at every single one of those, that in their forms, they all have an a value. And if we remember what a value meant in transformations, this means that we can tell if in each form if the quadratic was reflected or not. Remember, a reflected quadratic will look like that. And then my non-reflected look like that. Okay, so let's apply this to some problems. So given the equation, circle the key feature or key features that are easily identified with the least amount of work in the given form, and then determine those key features. Circle all that apply. So this first one, I see a quantity being squared, which means that is vertex form. So I should be able to tell the vertex. And we talked about we can tell reflection in each one. The last thing I forgot to mention was that axis of symmetry. So your axis of symmetry is when we have that quadratic, it's that line of symmetry right through the vertex. So if I can tell the vertex, I also can tell the axis of symmetry. So we talked about the vertex is your horizontal and vertical shift from here. So if I look here, this is going to go right 7, up 5. So my vertex is 7, 5. Right 7, up 5. A reflection is determined by that a value. So that a value is negative. So in this case, is it reflected? Yes, because that A value is negative. And then last but not least, the axis of symmetry. So we talked about it being that vertical line. So if I were to sketch this function we're dealing with now, the vertex would be 7, 5, and it would be reflected. So it looks something like this. If I were to draw that axis of symmetry, it goes right through that vertex. Vertical line has x equals, and then our x value is 7 of our vertex. Okay. Next one is in factored form. I can tell that because of those two sets of parentheses being multiplied together. And in factored form, I can easily tell my x-intercepts, and I can always tell if the graph is reflected. So I'm really going to highlight that one for each time. So x-intercepts, we said we needed to set each factor equal to 0. So x plus 2 equals 0, which means one of my x-intercepts is negative 2. The other one is a little trickier, which is actually why I did it. So I'm going to add 4 to both sides and then divide by 4. So those are my two x-intercepts. Then to tell if it's reflected, I look again at that leading coefficient is 1/4. That's positive, so the graph is not reflected. And then last but not least, that one's in standard form. So in standard form, I can tell my y-intercept, and I can always tell if it's reflected. So for the y-intercept, we talked about that being your constant at the end. So my constant at the end is 54. Reflected, I'm looking at that a value. That's a negative a value, which means it is reflected. And that's a review of your key features of quadratics.